Good morning, everyone. Welcome to the first day of online lectures. So we're going to start today by going over kind of some of the announcements over the last few days, since everything is moving very fast. Figured we should do a little bit of update. Hopefully this kind of works out. If you have any problems, remember to email me. This is the first time I'm doing something like this, so any advice, any feedback is greatly appreciated. So as you can see, this is how lectures are going to be. Everything's going to be kind of similar, except you won't get to see my face and I won't get to see yours, which is not as fun, but this is life. And then I'm going to try to break these lectures up into two parts so that they're not too long. I'd like them to be roughly 20 to 25 minutes max each. Like this, you can take a little break in the middle, have a little cup of tea if you want. Here's a little cup of tea because it's nice and hot. That's horrible, but anyway. So quizzes, if you haven't done the quiz, pause right now, take the quiz. There's quizzes every Monday, as normal. Starting at 9:30. So make sure to do that now if you haven't done it. I mentioned this in class on Friday. It was also on my website. It was also emailed out. So if you missed today's quiz, if you're watching this after 10 o'clock and the quiz is already closed, there's not much I can do. I gave a lot of warning. Email me if you do have problems, and we'll figure it out. The quiz should last 15 minutes, etc. Exams. So I sent out an email asking people their advice for the second midterm. So obviously I canceled the in-person one because we're not doing that. But I think a lot of people were worried about doing having the final be worth 60% of the grade, which makes 100% sense. And so I think the idea was to do some kind of take-home midterm, and 95% of people so far have voted for that. And since almost everyone has voted, I'm just going to go with this. We're not going to wait until Tuesday. And so it's going to be a take-home midterm. So basically what this is just a homework assignment. It's homework. So basically, I'm going to give you your exam Monday morning, and then I expect you to do, so given Monday, due Friday. So please make sure to hand it in by Friday. Obviously by Friday, I'm not giving a time. That means you have up until midnight. At 12:01 Saturday morning, aka Friday night, that will be officially late. You can hand it in late. There's a late penalty of 10% per day. So every day it's late, you get a 10%. Was that what I had decided? Yeah, 10% per day. So yeah, just a heads up. Obviously there's no second chance, no makeup. For the obvious reasons of it's take home, so you have a whole week to do it when you want. We will still have, we'll still do a practice exam this Friday. This Friday, what day would it be? Today's the 16th, so 17, 18, 19, 20. Friday the 20th. And what I'm gonna say is next week, so next Monday, there will not be a quiz since you're doing the take-home midterm. So no quiz Monday, the 21 to 23rd. Next up, final exam. I found the university policy, luckily, and they're letting us do kind of what we want. So this is going to be take home as well. Take home exam. On the last day of class, given last day of class. And I'll give you the same number of days as our exam would have been. So basically it'll be due the 13th. Due 13th of April. That gives you 10 days. 10 days to do the exam. It'll be twice as long as it'll be longer than twice as long. It'll be definitely longer than the second midterm, so it will need more time. The reason why I'm doing it this way and not giving you more time is because it's going to take me a lot longer to grade. These things take a lot longer, and my TAs only have a certain amount of hours, and I'd like to finish them in an orderly amount of time. I love you all, but I do have a life outside this class, so I'd like to finish this earlier rather than later. And so, yeah, so that's the final exam. What else? Was there anything else? Office hours are normal. Office hours, normal times. Normal times. We're using Discord for this. If you have questions, you can use Discord. If you don't like Discord, just email me. Don't like Discord, or it doesn't work, just email me instead. We can figure something out. Discord is definitely not required. It's just a nicer way to kind of do things for me. I know it has limitations, such as we can only have 50 people on the voice chat at any given time. So I know that's a limitation. But the problem is Zoom is not working the way we need for a class, the way I have structured. Unfortunately, Zoom is more made for the traditional learning ways of like the teacher stands there and forces you to learn information through slides or whatever, and no one actually learns anything. Unfortunately, we can't really use Zoom. So hopefully this kind of does work. If I see Discord is not working very well, then we might do something else. But for now, I'm just going to leave it as is, so as there's not any confusion. I think that covers all the notes. If there's any questions, feel free to ask. And so let's start on the lecture. How long has it been? Okay, so let's start on the lecture. And let's kind of go over what we did last week. So last week, we started going over L'Hopital's rule. And remember what for L'Hopital's rule, we always need to first show that we either have 0 over 0 or infinity over infinity. So when we have two functions, f of x over g of x, and we're trying to take the limit, so something like this, here on the right, something like this, then if we have 0 over 0 on top, so 0 over 0, or we have infinity over infinity, then we can take the derivative of the top, the derivative of the bottom, and that'll give us the limit. We went over two different examples, one with 0 over 0, and we saw that this gave us a limit of 1. And then what we also did is we took a second example where we had infinity over infinity, and this gave us 0. Right, so obviously doing infinity over infinity or 0 over 0, it doesn't really mean anything, right? Remember I had gone over how this doesn't mean anything, right? You can't divide by 0, and infinity is not a number, so it doesn't really make sense. And so we did an exercise at the end of class, and we found that in this case we have 0 over 0, but we're getting that the solution is minus 6 square root of 2. So notice how this is some weird number. This basically kind of helps show that no matter what we do, 0 over 0 or infinity over infinity, we can get kind of any number we want. And that's why we're not generally going to be doing, you can't just do the normal methods for that. Next up, we looked at where we can use L'Hopital's rule. Remember, we need 0 over 0, infinity over infinity. And then we started looking at different forms that we can convert into L'Hopital's rule. So for example, one of the forms was infinity minus infinity. And remember, for this, what we want to do is we want to convert to a fraction, right? So that's what we kind of did. We converted this to a fraction. And then from there, when we have a fraction, we get 0 over 0, right? So we have 0 over 0 in the third line. And then we can do our derivative method. So in this case, we actually end up having to take the derivative multiple times. And we end up getting 1/6 as our answer. So basically, we have a way to do infinity or minus infinity. But that's not the only time we can actually use this. We can actually do similar things with other forms. And one of them is the form 0 times plus or minus infinity, right? We can't just assume just because we're multiplying by 0 that it's going to be 0, right? So let's see if this following function, the limit as x goes to 0 of 8x to the 4 natural log of 3x, what that gives when we're doing, I think this is wrong as well. This should be 3x plus 1. Why did I screw up with my natural logs recently? This should be plus 1 here. Because the natural log of 0 does not exist. Yeah. So, not sure why my brain was there when I was writing these notes. Let's actually make these black. So this is an error in the notes. This should say plus 1, plus 1. No, actually no, this one's correct. Never mind. Scratch that. And this is okay. And so basically what do we get? Here, when x is going to 0, right? This is going to give us infinity. Actually, let's do, yeah. And then this, if we remember the curve for natural log, the curve for natural log looks like this, right? This is 1, this is natural log of x. So this is minus infinity if I were to quote-unquote plug in 0. Remember, we can never actually plug in 0. That just gives us an idea of what we should do. So this will give us 0 times minus infinity. And so we have a form that's slightly different. And this one's a little more complicated. And so basically, we're still going to do the same thing, but we're going to convert this to a fraction just like we did to the last one. So convert to a fraction. And basically what we do is we take this beginning part, the part that's 0, and we push it underneath. So what do I mean by that? I take the limit as x goes to 0 of 8x for natural log of 3x. And what I'm going to note is that, here, I'll do this up here, that 8x over 4, this is just 1 divided by 8x to the 4, right? So in this case, you can kind of see that this is basically the same thing. And it's a little convoluted, but we're going to write it this way, and we're going to see we're going to see that this makes this different, right? So now we have this function, right? And what does that give us? Here we have infinity on the top. So here we have minus infinity. Here now, because we put it on the bottom, we have 1 over 0. So 1 over 0 is infinity, right? So in this case, remember where this is scratch work, because we can't actually divide by 0. But we have infinity over infinity, so we can use L'Hopital's rule. And so let's do it. So I gave the answer too quick, so let's wait. So let's take the derivative. So derivative of natural log of 3x. This is just 1 over 3x, right? We take the derivative, this chain rule, so 1 over what's inside is 3x, times what is inside, so this is just 3. And then we take the derivative of what's on the bottom, and what's on the bottom is 1 over 8x to the 4. So what does that give us? This is just 1 over 8. The x to the 4, 1 over is just x to the minus 4. And so we get x to the minus 5. And here I would get a minus 4 in front. So this is nothing more than minus 1/2 x to the 5. So let's multiply these together. Therefore, we get that that limit, come on, fingers, that limit of x going to 0 of natural log of 3x over 1 over 8x to the 4 is equal to the limit as x goes to 0 of, this is on top, so we get 3 over 3x. So I guess this I could have made easier to 1 over x, so let's do that. So 1 over x divided by minus 1 over 2x to the 5. So what does that kind of give us? What we have here, we can divide, right? So this gives us, let's move this up. Of minus 2x, 5 over x. So we get limit as x goes to 0 of minus 2x to the 4. And this we should just see is equal to 0. And so I'm going to pause the video there because it's been, oh no, we still have time. Okay, let's do one more example. Let's do the next section. Remember, if there's questions, I'm on Discord, so just ask. Okay, so let's look at the next form. And so we can do a very similar thing with these forms: 0 to the 0, infinity to the 0, and 1 to the plus or minus infinity. The problem is they're a lot more complicated. And by a little, I mean basically we're going to do something very similar to what we've been doing for a lot of cases, and that's actually to use the natural log. So when we have something to the something, the nice thing we want to do is take natural log, because if we remember, when we have natural log of something to the something, I can bring this something in front. And so we're going to use that property to make our life a little easier. So what we're going to do is we're going to do this by an example, and we're going to look at the limit as x goes to 0 of x squared to the x squared. And so first let's see that this is one of these forms, right? So this will give us 0 inside, right? So this is 0, and then this is 0. So we get 0 to the 0, so we have this form. So we're happy. So we're going to convert it into a natural log. And we're going to do this just by taking the natural log of everything, right? So we have this, x squared. And so let's see what this gives us, right? So what does that give us? We have the natural log. So what we can do is this natural log and the limit commute. So what basically this means is I can move this and interchange them. So the natural log, what I'm saying is the natural log of the limit as x goes to 0 of x squared to the power x squared. This is just equal to the limit as x goes to 0 of the natural log of x squared to the x squared. And now, since I have the natural log of something, I can use the rule here. I guess let's give this a little star. And we're going to use star here. And here I can bring this limit in front. So here we have x squared times the natural log of x squared. And notice now, what do I have? I have 0 times minus infinity, just like the last problem. Right? Just like last problem. And so what am I going to do? I'm going to take this x squared and I'm going to put it underneath, just like I did. So this is equal to the limit as x goes to 0 of natural log of x squared, and then 1 over x squared. So here we have infinity over infinity. And here we can use L'Hopital, since we have minus infinity over infinity, since equals, yeah. So let's look at these derivatives. Let's see, I'll do these in the top left. So natural log of x squared, d dx. So this is what? 1 over what's inside, x squared, times the derivative of the inside, so 2x. So we have 2x over x squared. This is equal to 2 over x. And then the derivative of the bottom is d dx of 1 over x squared. This is the derivative of x to the minus 2. So this is just equal to minus 2x to the minus 3. So this we get is equal to the limit as x goes to 0 of 2 over x over minus 2x cubed. So these 2's we can cancel, and we get limit as x goes to 0 of minus x cubed over x is equal to limit as x goes to 0. We'll cancel one of these x's. This cancels, this becomes a 2 of minus x squared. So this is just 0. And so what does that give? But notice how this is equal to, so what we have is the natural log of the limit as x goes to 0 of x squared to the x squared is equal to 0. So we have this natural log. So how do we solve this? We solve this by taking both sides to the e. So I take e to both sides, and this will give me limit as x goes to 0 of x squared is equal to e to the 0, which is equal to 1. And that is our final answer. And so this is slightly confusing, especially since there's not me to be able to answer any questions while we're doing this. So if you have questions, ask them. But in essence, I'm going to review kind of what we did. What we're going to do is, in essence, we follow the following steps, right? So we let L be the limit. So we let this be our limit. And we have some function, f of x. So remember here, this f of x is of type, and we had 3 different types here on the top, right? We have 0 to the 0, infinity to the 0, or 1 to the plus or minus infinity. And then from here, we took the natural log of both sides. Find ln of L, which is just equal to the limit as x goes to a, ln of f of x, right? So now we're doing a chain rule kind of idea. And this is going to give us some number n. And then finally, our limit, so L is equal to e to the n, right? So because here when we take e to the ln of L, this is equal to L. And e to the n is equal to e to the ln of limit as x goes to a of f of x, right? And this is just equal to our limit, right? So this is equal to n. Yeah. Yeah. So this is the thing. I would say there's a problem next. Oh, that's it. So these are the 3 points. The next problem is actually you testing it out. So take 5 minutes. Wait, we have... Okay, so with 15 minutes quiz. Yeah. So do this. Yeah, rewind, sorry. So I would say do this problem, pause the video for 5-10 minutes, try this out, and then after you've tried this, unpause the video and do this.